Hello everybody. You are watching a Novartis Enterprise Architecture training session. We hope very much that you will enjoy the information we share, and we welcome any feedback you want to share with the broader architecture community. In this session I will explain in detail those terms and concepts of the Enterprise Architecture taxonomy, which I deem most crucial. So you will learn about their distinct attributes as well as about key differentiations. Also, I will make sure that important inter-term relationships will be highlighted and given star billing. So I will introduce you to capability, service, application, platform, and technology. I will also explain two important differentiations which are cross-cutting these terms: functional versus non-functional, as well as business versus technical. Last but not least, I will illustrate all key concepts by using concrete examples in order to help you better grasp the respective idea. If you already have explored the EA taxonomy a little bit, then you have certainly familiarized yourself with the meta-language concept that we based our development approach upon. All terms that I will introduce during the session are positioned on the meta-language level called Novartis EA Taxonomy Level 1 and are highlighted yellow here on this slide. The terms are capability, service, application, platform, and technology, as you can see. Furthermore, we distinguish two important dichotomies. I have marked them red here, and they are crucial because they determine a quite fundamental theme which is cross-cutting through all concepts. The first dichotomy is spanned over functional versus non-functional, and the second one across business versus technical. Before we dive into each of the terms' definition, I rearranged them a little bit, as you can see here on this slide. Technology on the left-hand side is referring to a concept that we consider controlled by a vendor, as the leftmost pillar is named. Application, service, platform, and capability on the other hand side are under the control and lifecycle ownership of Novartis. The rightmost two pillars quite nicely show how the connotation of business versus technical overlays and crosscuts through capability, service, application, platform, and even though not prominently shown, they both validly qualify technology also. I will use this outline as an agenda, so I will stroll through it and shed more light at each one of these terms. We will start now with capability. Capability is a term which refers to the immaterial helpfulness, usefulness, or utility of something. Since capability expresses the usefulness of something, the term capability can also be understood as the response to a need that somebody had. This means nothing less than capability and need, or its synonym requirement, are two inverse sides of one and the same coin. Also, you can think of capability as synonym to ability. I want to use a non-IT example quickly to dip a little further into capability. Let us take the example of a house, as this is currently sketched here, and understand the difference between functional and non-functional capabilities. Think of a functional capability as a useful property of something that addresses a primary purpose, objective, need, etc. You can think of primary purpose also as the what something offers to you. In the house example, an appropriate functional capability is, for example, protection, because a house protects you from weather conditions like thunderstorms, rain, cold air, etc. Another primary purpose, i.e. functional capability, that a house supports is privacy, because a house provides you private space by non-transparent walls, for example, which shield you from external observation. Now, what are non-functional capabilities all about? You can think of them as attributes to a functional capability, where functional capabilities express the what side of something. The non-functional capabilities express the how side of this. Synonyms that are often used for non-functional capabilities are quality aspect, quality attribute, or simply just quality. In the house example, a non-functional capability of the protection function could, for example, be reliability, like for example a measure of how much storm the walls and roof of this house could actually stand. Another non-functional capability example of the protection function could be extensibility, so a measure of how easy it is to introduce a dormer to the roof at a later stage or stand up a separate garage for a second car once your kids have grown up and claim their own space. Now, here is a slightly more formal definition. A capability expresses the ability of an entity, for example, department, organization, person, or system, to achieve its objectives in relation to its overall mission. The term capability introduces the notion of something which can be referred to, understood, and discussed irrespective of any future realization of it. So think of capability as being neither a process, nor an organizational unit, nor a business function, nor a computer system, nor anything of that like, but think of it as the value contributions that things like processes, org units, business functions, computer systems, etc. make. Capabilities in the context of IT are provided by computer systems. Furthermore, they can be consumed by other systems as well as by human beings like administrators, users, super users, etc. Let's look at two examples. I start off with the technical capability side of the house. Resolve the name of a technical object, for example a printer, into this object's IP address. I consider this one to be a technical capability because it enables the implementation of other capabilities rather than being a capability endpoint to the business itself. This would then obviously qualify as a business capability. Now let us look at a business capability to contrast the notion of technical. Store, qualify, and classify a document persistently or search a classified document based on its attribute values. Now, doesn't this sound a lot better from a business and ultimate usefulness perspective? Sure. Furthermore, and as mentioned earlier, functional capabilities express what the system is able to deliver. To deliver in response to appropriate requests and in order to meet its overall value proposition. Functional capabilities express what a system can and will do. They correspond to the what. In contrast to functional capabilities, non-functional capabilities do not express what a system will do, but rather how a system will do what it does. So non-functional capabilities express a system's quality attributes. In the case of business capability, so the left vertical pillar here on this slide, non-functional capabilities are stating the need for the function, which is outlined above, to perform and execute reliably, fast, securely, as well as in a properly usable fashion. A similar set of non-functional capabilities express the quality needs for the technical capability on the right-hand side. The next term that we are going to give a closer look now is service. A service is the provision of specified, non-physical value to a customer through repeatable activities. A service is self-contained, contributes as part of a capability to execute a process, may be composed of sub-services, and is a black box to its consumers. The ability to provision services in a repeatable manner is often based on computer systems, organizational as well as process means. Different connotations of service exist in the IT world. An example of these is the notion of web service. Web services are one of many other flavors of the well-known remoting or remote procedure call paradigm, where web services, as their name already indicates, expose their callable endpoints via web protocols. There are many other technically flavored notions of the term service in IT. However, I recommend that you, rather than trying to clarify what shape a service finally takes, approximate the concept of service along the attributes by which it exposes itself to its outside. So the relationship between service and other key terms is as follows. A service provides as well as it consumes capabilities, for example from other services or from applications. Capabilities a service provides are consumed from end users directly or from other applications, which may in turn underpin yet another service. Then there is another relationship. The computer system proportions of a service are realized based on applications and platforms, where both of these terms will be defined in a minute. Services can furthermore be distinguished into technical and business services, where technical services provide technical capabilities and business services provide business capabilities respectively. Beyond its relative description, the concept of service is best understood based on an understanding of its mandatory attributes. The consumer rationale attribute, for example, is an indispensable result of service delivery. A service must be accessible, callable, and utilizable for service consumers. It must be rendered to a service consumer at their dedicated request. Another attribute of a service is delivery point. It expresses location of the requesting service consumer and potentially a service's logical or physical interface. Impairment duration is another important service attribute which describes the maximum allowable duration of service impairment and usually serves as a reference for prioritizing activities. Then we have service delivery unit, which is a description of the basic measurement unit, which comprises delivery of all service benefits. This attribute is referred to each singular service request as well as each singular service consumer. The next attribute is service availability, which expresses, for example, the hours of the week with sufficient service delivery preparedness. Then we have support availability, which specifies the hours of the week where the service desk maintains readiness. And last but not least, service delivery price, which is the price tag associated with delivering the specified service offering. As you can see, we can fully define what service means and stands for by defining a clear set of service attributes as well as what each of these means. Whether such service is then 99% realized by a computer system or only to a 10% extent, while the remaining 90% are based on manual steps, people, processes, and non-IT technical systems, does not really matter anymore. So shift your focus from what a service internally is, so the white box view onto service, to what a service looks like from the outside, which is the black box view of it. Let us look also at a service example quickly. In the business service space, we could imagine services which provide document management capabilities to business users. For example, a Novartis Documentum service or a Novartis archiving service. On the technical side, we could imagine directory and naming services which we may have named Novartis Active Directory Service or Novartis DNS Service, both providing the set of capabilities we used in an example earlier. Remember that even though the chosen service names sound as if we speak about pure technical systems, a service in the EATaxonomy sense is more than just that. It is comprised of people, processes, SLAs, and many more supplementary means as outlined earlier. Next, we will look into the terms technology and application conjointly, since they are best understood by their mutual reference. An application is a computer system that is implemented based on technology. In plain English, one could actually say that an application is what its name says. It is an application of technology. So in contrast to technology, which represents a commercial off-the-shelf computer system, the term application refers to a computer system that Novartis tailored, customized, integrated, for example with other applications, in one way or another. Key differentiator between the concepts of application and technology is that the application ownership is with Novartis, whereas the technology ownership of a technology used by Novartis remains with a vendor or supplier of it. Make sure you don't confuse the terms technical and technology. Technology refers to something Novartis grabbed off the shelf from a vendor shop window. So for example, an ERP system compile base like the one from SAP. Another technology example is Microsoft's Active Directory system, as this is waiting for customers out there in Microsoft shop window. Both the aforementioned ERP as well as the Active Directory compile base clearly qualify as technologies in an EA taxonomy sense. However, only one of these two technologies is considered to offer technical capabilities. Only the Active Directory system does this. It offers capabilities which we would qualify as technical because they enable other systems to be based upon it and do not deliver capabilities to the business directly. The ERP's compile base on the other side is considered as a semi-final product offering business capabilities. The IT standards that we manage here at Novartis are a collection of both systems which offer business as well as technical capabilities. However, what both types of IT standard entries have in common is the following aspect. An IT standard always refers to a shop window version compile base of a respective Novartis supplier. Along the just said, it is no surprise that we distinguish between technical and business applications, as we did with capabilities and services earlier. The code base of the SAP ECC HR module, for example, is technology. Novartis has licensed this computer system which offers business capabilities. The moment in time Novartis starts installing, tailoring, integrating, customizing, patching, etc., this off-the-shelf system, the Novartis-specific application of SAP's technology turns into an application which is owned, operated, further evolved and lifecycle managed by Novartis. Because SAP's technology is there to establish business capabilities, the application that Novartis built based upon it will be a business application. Novartis Active Directory, AD, for example, is a technical application because it implements a Novartis-specific directory and object schema. It also implements a Novartis-specific directory information tree. Furthermore, this technical application is footprinted into the Novartis network. Its technical components are placed in Novartis data centers, etc. The difference between the technical application that is called Novartis Active Directory on this side and the technology it is implemented upon is very important. It is crucial since Microsoft only manages their off-the-shelf product but not Novartis application of it. In this example, the respective technology is called MS Active Directory. It may well be that the Novartis Active Directory application has security flaws, performance problems, availability issues and so forth, which Microsoft's MS Active Directory technology does not have as such. Therefore, it is important to be able to clearly distinguish between application as an application of technology, as opposed to technology, which is the computer system sitting in a vendor's shop window. The last term we define here is platform. It helps the understanding to define platform in relation to application, which is why I highlighted app yet again here in this slide. A first aspect you certainly recognized on one of the previous slides is that a platform is an application itself. This makes sense since a platform is implemented based on commercial off-the-shelf technologies, very similar to how we define this for an application to be a distinguishing factor. So if a platform is an application, then what distinguishes platforms from apps? First of all, platforms have a provider relationship to apps. This means that platforms enable or host applications. Ultimately, they provide their capabilities to consuming applications. A very common model which platforms adopt is the following. A platform serves as a container to an application. This means that an application is deployed into a platform and then lifecycle managed by the platform container during run and hosting time. A platform is a composite of multiple applications. A technical platform is comprised of multiple technical applications, whereas a business platform would be a composite of several business applications, which may be combined with a couple further technical apps for the business platform's non-functional matters. While platforms are comprised of applications, a platform has its own dedicated lifecycle, which is decoupled from the ones of its apps. The platform's lifecycle purpose, though, is an integrated one, where an underpinning application manages its own lifecycle in a context-agnostic fashion. The lifecycle of a platform is considering the platform as a coherent whole, spanning the lifecycles of many independent applications, while these need to be evolved at the same time in an integrated and fit-for-platform purposes fashion. Platforms usually implement more stringent non-functional capabilities like reliability or availability, and therefore are equipped with more elaborated means regarding their ITSM processes, tools, monitoring, backup and recovery systems, etc. This is important since platforms usually offer an environment that logically separates consuming applications, serves them concurrently, transiently, permanently, and in a multi-tenant manner. So if a platform goes down, then usually this has a dysfunction impact to its served applications. The key customer of platforms is IT, for example, application and platform managers, who benefit from capabilities which are reliably offered by respective underpinning platforms. As the examples show on this slide, on this last one, there is a business platform called Novartis HR Core, which is comprised of the two business applications SAP ECC HR module and Novartis Identity module. The Novartis HR Core business platform serves on the other side, atop of it, two well-known Novartis business applications, PMP and the Talent Management System, TMS. On the right-hand side, we see a technical platform called Novartis Web Hosting, WS, where WS stands for WebLogic Server. This technical platform is based on two fictitious technical applications called Novartis MOM module, where MOM stands for Message-Oriented Middleware, and Novartis TX Monitor, where TX stands for Transaction. Further up that food chain, the technical platform, Novartis Web Hosting, serves a business application called Clinical Trials Web. I hope you enjoyed this session and that I was able to stimulate your curiosity. If during this session any questions came up, you can always reach out and contact the Novartis Architecture Board or me personally for a discussion, from one architect to another. Please ping me anytime at ingo.arnold@novartis.com.